Could humans truly hibernate like bears, but in the cold void of space? It's an idea that stretches our imagination, yet holds a kernel of possibility. The concept of human hibernation in space opens up a Pandora's box of questions. Could the human body withstand such a state of suspended animation? How would it affect our minds, our health, our very sense of time? Yet the potential benefits for long-term space travel are tantalizing. Imagine journeying to distant stars, not in a matter of generations, but within a single human lifespan. We observe hibernation in the animal kingdom, from the deep winter sleep of bears to the metabolic slowdown of hummingbirds. Could we, intelligent and adaptable as we are, harness similar mechanisms for our benefit? The idea may seem radical, even fantastical, but it's one that scientists and researchers are seriously contemplating. Now let's delve into the history of hibernation technology to better grasp this fascinating concept. The idea of human hibernation isn't as novel as you might think. The concept has been floating around for centuries, finding its roots in ancient mythology and folklore. Remember the tale of Rip Van Winkle, a man who slept for 20 years and awoke to a world dramatically changed. These stories sparked our imagination, but it was science fiction that truly propelled the idea into the realm of possibility. The mid-20th century saw a surge in science fiction literature, with visionaries like Arthur C. Clarke and Robert A. Heinlein exploring the concept of suspended animation, or sleeping the stars away. These narratives ignited scientific curiosity, leading to the first serious studies in the field. In the late 1960s, scientists began to explore the idea of inducing a state of hibernation in humans, similar to what we see in some animals. They proposed that slowing down metabolic processes could enable humans to survive long space voyages. However, these early theories faced significant challenges. Firstly, there was the issue of temperature. While some animals can hibernate in freezing conditions, humans are not naturally equipped to withstand such low temperatures. Then there was the question of time. Could the human body and mind endure an extended period of inactivity? And let's not forget the ethical implications. What if something goes wrong? Would it even be right to subject someone to such a procedure? Despite these concerns, scientists were not deterred. They continued to delve into the mysteries of human hibernation, spurred on by the tantalizing possibility of deep space exploration. But it was clear that they were limited by the technology of their time. They could theorize and hypothesize, but they lacked the tools to make their dreams a reality. While the early theories were promising, they lacked the technological advancements we have today. But as we'll see, the pursuit of human hibernation was far from over. As technology advanced, so too did our understanding and capabilities. Stay tuned as we delve deeper into the fascinating journey of human hibernation. As technology progressed, so did our understanding of the possibilities. We began to unlock the secrets of the human body and the universe, pushing the boundaries of what was previously conceived. One of the key developments was the concept of induced hypothermia. This medical treatment, often used for traumatic injuries, involves lowering the body's temperature to reduce the metabolic rate. This slows down the body's functions, effectively putting it into a state of hibernation. It was a significant step forward, suggesting that a similar state of suspended animation might be possible for long-term space travel. Suspended animation itself was another major breakthrough. It's the idea of slowing down life processes by external means without terminating life itself. Picture a state where time stands still for the body, allowing months, even years to pass without the usual biological toll. This concept, straight out of science fiction, started to gain scientific credibility. And then there was cryonics, the process of preserving bodies at extremely low temperatures with the hope of future revival. The thought of freezing humans to later reanimate them once we've reached a distant star system ties directly into our quest for hibernation in space travel. But these technologies were not just theoretical musings. They were grounded in real, tangible advancements. For instance, the discovery of certain chemicals that could prevent damage caused by freezing and thawing cells opened up new possibilities for cryonics. Similarly, advancements in medical technology allowed for more accurate control and monitoring of induced hypothermia. The journey was not without its hurdles, of course. Each technological breakthrough brought its own set of challenges. The ethics of cryonics, the medical risks of induced hypothermia, and the unknown long-term effects of suspended animation were all subjects of heated debate. But as with any pioneering venture, the path to progress was paved with both controversy and discovery. These advancements didn't just push the boundaries of our knowledge, they reshaped them. They took the concept of human hibernation from a distant dream to a close reality, from the pages of science fiction to the brink of scientific fact. These advancements paved the way for practical experimentation. The theoretical became tangible with the first practical experiments. These experiments were a turning point in our journey towards the dream of human hibernation in space. The scientists, as audacious as they were brilliant, embarked on a mission to test the limits of human endurance and the possibilities of induced hibernation. The earliest of these experiments attempted to mimic the natural hibernation process seen in animals. But of course, we humans are not bears or hedgehogs. Our bodies, our metabolisms, are wired differently. The initial trials faced setbacks, unexpected physiological reactions, medical complications, and even ethical concerns arose. But these were not failures. Rather, they were stepping stones, guiding us towards a deeper understanding of the complexities of human hibernation. These early experiments gave rise to a myriad of ethical and medical challenges. The notion of inducing a state akin to hibernation in humans raised questions about consent, risk, and the boundaries of scientific exploration. Each experiment was a tightrope walk between innovation and ethical responsibility. But it was through navigating these challenges that the scientific community began to establish guidelines and protocols, ensuring the safety and dignity of all participants. From a medical perspective, the experiments illuminated the enormous task of manipulating the human body's natural rhythms and functions. They revealed the delicate balance of our metabolic processes, the intricate dance of hormones and enzymes that keep us alive and functioning. The task was not just to induce hibernation, but to ensure a safe and controlled revival. It was a complex puzzle, and each experiment added a new piece. These experiments, though fraught with challenges, were not in vain. Each trial, each error, each success brought us closer to understanding the enigma of human hibernation. They were the first steps towards turning the impossible into the possible, the theoretical into the tangible. These experiments brought us one step closer to the dream of human hibernation in space. Today we stand on the cusp of turning science fiction into reality. Let's delve into the current state of hibernation technology. It's an exciting time, with researchers around the world tirelessly working to crack the code of human hibernation. While we haven't yet perfected the art of putting humans into a deep sleep for extended periods, we're making significant strides. Just recently, a team of scientists has developed a method to slow down the metabolic rate of mice, effectively putting them into a state of hibernation. They're now working to scale this up to larger mammals and eventually humans. This could be the key to unlocking long-term hibernation in humans, a development that would revolutionize space travel. Elsewhere, researchers are exploring the use of synthetic molecules to induce a state of suspended animation. These molecules could potentially slow down the body's biological processes, allowing humans to survive for extended periods without food or water. Imagine, if you will, a future where astronauts could journey to distant planets while in a state of hibernation, waking up refreshed and ready to explore new worlds. But the implications of human hibernation technology extend beyond space travel. It could also pave the way for the colonization of other planets. By reducing the need for resources during the journey, we could send larger numbers of people to establish colonies on distant worlds. In this way, hibernation technology could be the key to ensuring the survival of the human species. Of course, there are still many hurdles to overcome. Long-term hibernation could have unforeseen effects on the human body, and we're still a long way from being able to induce and reverse hibernation at will. But with ongoing research and technological advancements, these obstacles are not insurmountable. We're living in an era of unprecedented scientific discovery, and the possibilities are only limited by our imagination. The dream of human hibernation in space may not be just a dream for much longer. The journey towards human hibernation in space is a thrilling tale of science and imagination. We embarked on this exploration by delving into early theories that dared to imagine the extraordinary. Then we stepped into the realm of technological breakthroughs, where science fiction started to transform into reality. The advances in technology paved the way for practical experiments, pushing the boundaries of what we previously thought was possible. Today, we stand on the precipice of a new era, where human hibernation in space is no longer just a distant dream, but a tangible reality within our grasp.